In the dry heat of the Kalahari, the vulnerability of life is visible from the first moments. As the background sound fades, the scene reveals a stretch of sand that extends to the horizon. The red ground surface retains heat throughout the morning and produces faint heat distortions in the dry air. In a shallow depression, a group of adult female elephants move slowly in a tight formation. Inside that protective formation, the young individuals stay close to their mothers to avoid direct sunlight and maintain balance on the soft terrain. In the dry conditions, the first steps always occur early because the herd cannot stop for long due to the risk of dehydration. The adult females move in synchrony and create shadows that reduce heat from the ground. Their wide ears release heat and block sunlight for the young elephants. Inside the formation. This is a passive form of protection that develops naturally from the long-established social behavior of elephants. Not far away, beneath sparse thorn bushes, a group of lionesses is resting. They rarely target adult elephants, but the presence of young elephants always receives additional attention, especially in a place where prey is limited, such as the Kalahari. An experienced lioness in the group raises her head and faces the wind to detect the elephant herd from a distance. She observes the terrain ahead, where a low slope lies in the path of the elephant herd, a location that could alter their protective formation briefly. The elephants quickly detect the unusual signal. There is no panic. Only small but clear adjustments in their formation. One adult steps forward and the others shift into a curved line that places the young individuals deeper at the center. The lionesses begin to approach and keep their bodies close to the ground to conserve energy and reduce visibility under the intense sunlight. The lead elephant emits a short, low-frequency call that carries across the area and prompts the group to expand their formation and move forward proactively. The distance between the two species narrows quickly and forces the lions to withdraw before they become encircled. The elephants maintain their defensive formation for a short period before returning to their regular pace. The young elephants continue to move inside the protective circle beneath the narrow patches of shade created by the herd. In the Kalahari, the journey toward water sources is always long and full of risk. The temperature rises rapidly, the open terrain offers little cover, and the wind carries signals of other predators. No moment is entirely safe, but the cohesion of the formation allows the elephants to pass through the most sensitive period of the day. The afternoon in the Kalahari does not cool after the midday heat. Heat rises from the ground in thin, vibrating layers that distort the horizon in the intense air. This is the time when many species reduce activity. But it is also the period when lions often make their boldest decisions. A group of lionesses hides under thorn bushes and monitors the slow movement of the elephant herd that is heading toward a shallow depression with remaining moisture. In the dry conditions, every hunt depends on energy balance, because a long chase can exhaust a lion in only a few minutes. However, a young elephant that struggles to keep pace with the herd provides a large amount of nutrition and can sometimes cause lions to attempt an approach. The lionesses move forward with small steps and keep their bodies low under the bushes to reduce visibility. They do not rush in directly, but close the distance from two angles to increase the chance of approaching without triggering early alarm. The elephants detect the threat not through sight, but through a slight change in the wind flow. The scent of lions, even when faint, is enough to alert the adult females. They stop their movement rhythm and adjust their formation within seconds. The large individuals form an outward-facing arc, while the younger ones move deeper into the center. The height and mass of the adult elephants block most low angles around the herd and create a natural layer of protection that develops from their stable social structure. The lions continue to advance a short distance. They do not attack immediately, but observe the terrain where a low slope may cause the elephant formation to open briefly during a directional change. This is the type of opportunity lions often search for in an environment where prey is limited, such as the Kalahari. On the elephant side, the three largest individuals step forward and maintain a slow but steady pace. Each heavy step causes a small vibration in the ground. Their ears spread wide and their tusks point outward as a clear warning signal to any predator observing them. The distance between the two species closes enough to alter the lion's decision. They pause briefly and then move back toward the thorn bushes to avoid direct confrontation. There is no rapid retreat. only a controlled withdrawal to conserve energy and prevent injury. When the threat decreases, the elephants reduce their defensive arc and continue moving through the low-lying area where the mud surface can retain moisture longer. During hot days. In the Kalahari, each segment of ground crossed removes one layer of risk. The lions do not gain an opportunity, but they also avoid conflict. The elephants do not engage in a fight. But they still expend energy to maintain alertness. This is how the large species coexist in this harsh environment. They do not exceed their limits, and they respond promptly to environmental signals. As darkness gradually covers the red sand of the Kalahari, the ground temperature drops quickly. The sudden shift between daytime heat and nighttime cold shapes the behavior of most species. For elephants, this is an appropriate time to travel farther. For smaller species, nighttime is the period with the highest risk because predator activity increases and the sparse vegetation does not provide sufficient cover. The dryness of the Kalahari does not follow a fixed pattern. Some years bring very late rainfall. Some years allow the shallow depressions to retain water longer. For wildlife, these fluctuations are not background elements, but ecological forces that require seasonal adjustment. Elephants move according to water holes, antelope move according to grass cover, lions move according to both factors. During the deep dry season, the remaining water holes become the center of the entire ecosystem. Elephants can dig into the mud to reach water. Monitor every shift around these areas. The low grass height exposes any species that steps into the water zone and turns each visit into a survival decision. Hyenas, which are among the most adaptable scavengers, depend on seasonal changes. When water sources decrease, competition among herbivores increases and feeding opportunities become more frequent. Hyenas track the signs of individuals that are weak, injured, or separated from their herds. During bright, moonlit nights, they gain better visibility in open areas. When rain arrives, the entire rhythm of life changes. Within a few days, the cracked, dry ground becomes covered with young grass. Beetles, termites, and insects reappear. Amphibians emerge from soil crevices to reproduce. Temporary streams form and attract antelope from distant areas. Lions then expand their patrol range because prey becomes more dispersed. For elephants, rainfall provides the most immediate relief. The water holes fill again, the travel distance to water shortens, and young individuals gain more time to rest. In contrast, rainfall makes prey scent harder to detect, and the fast-growing grass limits the lion's visibility. Which forces them to continue adjusting their hunting strategy. In the Kalahari, no strategy remains effective throughout the entire year. All strategies revolve around energy, heat retention, water conservation, movement efficiency, and the use of every small opportunity. From large elephants to small antelope, each species must constantly adapt to survive in an environment that supports life only through its own severity. The Cerrado spreads across central Brazil like a compact continent. From above, the landscape appears as continuous sections of grassland, shrubs, sparse forest, and seasonal streams. The ground in this region is maintained by fire. The low grass ignites quickly during dry season, thunderstorms, and burns fast before dying out. Leaving a layer of black soil. That soil becomes the base where new grass grows vigorously when the rain arrives. This cycle of burning and regrowth shapes the entire wildlife community of the Cerrado. On the open grasslands, the plains running species are the most visible. On windy mornings, rheas, which are the largest flightless birds in South America, move in small groups. Their long legs and strong thigh muscles allow them to escape danger without the need to fly. Rheas depend on speed and rapid directional changes to avoid predators such as pumas or South American foxes. When the wind shifts, they raise their necks high to observe unusual movement across the grass in front of them. In an open ecosystem with limited shelter, speed is their primary form of defense. At the edge of a seasonal stream, fresh tracks of capybaras and tapirs show that animals move nearly day and night. The Cerrado is not always harsh, but the instability of water forces animals to adjust their behavior weekly and sometimes daily. Small herbivores prioritize shallow areas when the rain begins because new grass grows quickly. In contrast, larger animals such as tapirs are more active at night when temperatures drop, and they can travel long distances with lower water loss. This ecosystem places significant pressure on predators. In open grassland patches, predators struggle to approach without being detected. As a result, many carnivores of the Cerrado rely on strategies based on silence, camouflage, and long-distance observation, rather than extended chases. These strategies will become central in later sections when examining the maned wolf, ocelot, jaguar, and puma, which are the four main predators that shape the food web here. At the moment, the Cerrado is in a fragile state of balance. The recent rainy season has left uneven water levels across different areas. Some depressions still hold moisture and attract many species to feed. Other areas have begun to dry again and force wildlife to move. The natural burning cycle of the dry season will soon return, altering the ground surface in only a few hours and requiring every species to adjust its strategy. Plains-running species such as rheas and pampas deer are the first to respond. Their speed, movement direction, and herd spacing become important signals for the entire ecosystem. Predators monitor them. Other herbivores rely on their movement to choose when to shift locations. Raptors in the sky read the motion of the herds to predict where vulnerable prey may appear. When the sun rises high, most animals on the Cerrado grasslands search for shade to avoid the heat. However, on the low grass zones near the sparse forest, the maned wolf of South America continues to follow its own activity pattern. Its long legs, slender body, and raised mane make it resemble a deer more than a wolf. This non-traditional body structure suits environments where the grass is low and the open space extends far. The maned wolf does not rely on long chases. It uses a low-energy strategy by walking slowly, watching slight grass movement, and striking downward in a sudden pounce. Most of its diet consists of small rodents, large insects, small birds, and a significant amount of fruit. During the dry season, when prey becomes scarce, they increase their intake of plant material to maintain energy under changing conditions. Their vertical pounce is a distinctive behavior. The maned wolf listens for rodent movement under the grass and then jumps upward before driving force into the suspected point. This hunting method conserves energy and suits the hot and dry environment where long pursuits are rarely effective. Not far away, inside the low forest patches, ocelots move quietly through the shade. Unlike the maned wolf that operates on the open grasslands, the ocelot relies on ambush hunting. Its small and light body and large eyes allow it to adapt to canopy cover, narrow trails, and areas with low light. The ocelot mainly hunts hares, small birds, lizards, and occasionally large rodents. Its activity follows the light cycle by avoiding daytime to reduce water loss and increasing ambush attempts at night to maximize cover. This species rarely competes directly with jaguars or pumas because it chooses denser habitats where larger species cannot move easily. Near seasonal water channels, jaguars hold a different position. Jaguars in the Cerrado are smaller than their relatives in the Amazon. But their bite force remains among the strongest of the American cats. Their attack strategy targets the skull or top of the head to end prey quickly and reduce energy loss in the hot climate. Cerrado jaguars are also one of the few large cats that operate frequently in water. They stay low along mud edges and wait for capybaras or young tapirs to move close before launching an attack when the distance becomes short enough. The shallow waters of the dry season increase hunting opportunities because prey has limited space to escape. At higher elevations, pumas or mountain lions use a wider strategy. Unlike jaguars that stay near water, pumas choose higher ground and open grasslands to hunt. Their biggest advantage is territorial flexibility. They can move between dry areas, sparse forest, and rocky terrain depending on where prey gathers. When pampas deer follow new grass, pumas adjust their routes accordingly. When tapirs retreat deeper into the forest during hot months, pumas shift their activity zones. This flexibility helps pumas and jaguars reduce conflict. They divide space horizontally and vertically, with jaguars near water and pumas in the higher and more open zones. These four predators do not create a chaotic competition system. Instead, their stratified strategies and habitat separation help maintain a stable structure in the Cerrado. Each species regulates a different prey group. Each species has distinct activity hours. This division keeps the fire-shaped grasslands balanced and prevents resource overload or collapse. Along the edge of a seasonal stream, patches of wet mud left after a short rain attract many species. Among them, capybaras are the most noticeable and usually move in groups of several to more than a dozen individuals. They maintain close spacing to monitor one another while feeding or resting. Capybaras depend strongly on water, so their movement routes reflect the seasonal stability of the Cerrado. When water sources shrink, capybaras gather around the remaining ponds, which are also areas that often attract jaguars. Jaguars commonly wait along the muddy edges where capybaras must approach to drink or cross. When threatened, the entire capybara group rushes into the water almost at the same time. However, deep water is not fully safe. Because caimans may ambush near dark edges and strike individuals separated from the group. Although capybaras are omnivores, they play an important role in grassland structure. Their continuous grazing prevents grass from becoming too dense and opens access for water birds and small herbivores. Near the water's edge. The paths created by capybaras also help rainwater infiltrate the soil faster, which supports moisture retention during the early dry season. Not far away, tapirs move through the sparse forest. This is one of the oldest mammal species in South America. with a large body, strong legs, and a flexible snout that helps select leaves, fruits, and grass near the water. Tapirs are mainly active at night to reduce water loss when daytime temperatures are too high. Each time a tapir crosses the mud, it leaves deep impressions that many other species use to locate water sources. Tapirs swim well and can submerge to avoid danger, leaving only the tip of the snout above the surface. Jaguars are their main threat. But tapirs are not easy prey because their body strength and tendency to rush straight into the river help them escape many pursuits. On softer soil, armadillos leave numerous small digging holes. Their keratin armor reduces water loss and protects them from small predators. Their diet includes insects, termites, worms, and occasionally fallen fruit. The largest ecological contribution of armadillos comes from their soil digging ability. Their long burrows aerate the soil and create conditions for rapid grass regrowth after fire or rain. When armadillos abandon old burrows, many other species such as turtles, snakes or badgers reuse them, creating a resource recycling chain characteristic of the Cerrado. On the low tree canopies, coatis add another movement layer distinct from ground-dwelling species. Female coatis usually live in groups, while adult males live alone. They climb efficiently with the help of their long balancing tails and use their sensitive sense of smell to locate insects, eggs, fruits, and decomposing animal matter. Coatis often appear in places where armadillos have disturbed the soil or along paths created by capybaras, which are disturbed zones rich in newly available food. These four large omnivore species have varied diets but share a common ecological role. They transport energy between the sparse forest open grasslands and water edges. Their movement patterns attract predators and help shape Cerrado dynamics across seasons. The routes they leave behind act as signals for raptors in the sky and carnivores on the ground to evaluate an area. In an ecosystem strongly influenced by fire and rain, these movements help maintain regenerative cycles and keep the Cerrado functioning steadily through each season. The afternoon in the Cerrado retains the heat of the midday sun. Winds from the sparse forest begin to move across the area and bring a slight amount of moisture. This is the time when the most specialized species of the ecosystem appear, with each species optimizing its body for a single food source or a single hunting strategy. On the grass near a large termite mound, a giant anteater moves slowly across the ground surface. Its long body, thick fur and large tail help block sunlight and reduce heat loss. Without teeth, the anteater relies entirely on its long, adhesive tongue to reach termites inside the hardened mound. It opens only small gaps in the softer parts of the mound and then withdraws quickly before the defensive termites gather. This strategy allows the anteater to exploit the termite colony for a long time without destroying the entire structure. When threatened, the anteater uses its strong front claws, which force many predators to be cautious when approaching. In the higher ground, the boa constrictor uses a completely different strategy. It remains motionless for hours, and uses its body pattern to blend into dry leaves and burned grass. The boa has no venom, and its strategy depends on strong constriction. When prey approaches, the boa wraps tightly and restrains movement to prevent escape. Each successful hunt can provide enough energy for many days, which suits the long dry cycles of the Cerrado, where prey becomes scattered and unpredictable. Along seasonal streams, South American otters operate in small groups. They hunt fish through coordinated actions. With some individuals diving to apply pressure from below, while others wait at narrow water channels to block escape routes. This method reduces energy expenditure during periods of low water levels and weak currents. Otters constantly monitor the water's edge because the same space is used by caimans for ambush. Not far away, a caiman lies almost motionless in the mud, with only its eyes and snout above the surface. Caimans hunt through ambush rather than long chases. They detect small vibrations on the water surface and strike when prey enters an appropriate range. In shallow and murky water, their rotational movement helps destabilize prey and maintain their advantage. During the dry season, when water sources shrink, otters and caimans must share the same space. Many encounters occur. But they do not always result in attacks, because otters avoid deeper water while caimans maintain dominance at fixed pools. The specialization of each species maintains clear energy flow between the grasslands, sparse forests, and water edges, creating a stable system supported by their differences in survival strategies. Along the Nile River, where shallow water meets deeper channels, hippos shape the living space around the flow. Their large bodies and efficient underwater movement allow them to influence most activity along the banks. When midday temperatures rise, water becomes the required refuge. Hippos remain submerged for long periods to limit heat loss and reduce energy use. Each group maintains a defined territory, expressed through position in the water, orientation toward the bank, and spacing between neighboring groups. The center of each activity zone is usually a single adult male. Its presence is reinforced through vocalizations, posture and jaw display behavior. Major conflicts rarely occur because the energy cost is too high in hot conditions. When clashes happen, they remain brief and end quickly. In the water, smaller individuals require protection from strong currents and accumulated surface heat. Adults stay close to one another to create stable water zones that reduce risk for the young members of the group. Underwater communication helps maintain cohesion and reduces confusion when hippo density increases. Feeding occurs mainly on land at night. Travel routes form from repeated movement over many years and create compacted trails across the ground. These trails divide grass types. Lower areas are grazed short, while higher patches become shelter for smaller species. When the dry season intensifies and water levels drop, hippo density rises in the remaining pools. Tension between groups increases, especially at access points to the bank or the last patches of riverside grass. The continuous movement of hippos directly shapes the terrain. They carve deep channels through mud as they pass. Which become pathways for fish to reach new pools. This movement benefits young crocodiles, otters, and waterbirds that rely on the remaining food sources during the dry period. Hippo's strength becomes most apparent when they defend group boundaries in the presence of crocodiles. An adult hippo can block and force a crocodile to leave shallow areas where hippos gather most densely. Across the Nile River ecosystem, hippos are not the top predators. However, their movements, trail formation, and influence on water distribution play a decisive role in shaping riverbank structure, which many other species depend on for survival. Along the Nile's floodplains, where mud and tall reeds limit visibility, herds of water buffalo move as a unified group. They do not rely on speed, but depend on herd cohesion to reduce risk from crocodiles and terrestrial predators. In a stable herd, young and weaker individuals remain in the center. A ring of adults surrounds them and forms a buffer zone. The herd has no fixed leader, but it reacts to the most alert individuals positioned along the edges. When the herd approaches the water's edge, which is a high-risk zone, it slows down and widens its formation. Large and experienced adults take the first positions. Unlike many herbivores that simply leave the area, water buffalo often hold their ground and apply counter-pressure. Adult individuals move toward the bank and use body mass or horn orientation to force crocodiles away. This group-based defense strategy increases safety during future visits to the water. In addition to crocodiles, water buffalo must also consider hippos. Hippos maintain clear territorial boundaries in shallow stretches. When a herd moves too close to these zones, hippos may display defensive behavior and push the herd outward. Such encounters are brief but frequent in the confined space of the dry season. As water recedes, mud thickens and access points narrow. This period presents the highest risk. Crocodiles gather at remaining deep channels, hippos hold the center of the water, and buffalo must approach through predictable routes where predators can anticipate their movement. However, the collective defense of water buffalo remains effective. Adult males usually stand along the perimeter and create a protective barrier against predators. Even lions, which are capable of hunting buffalo in coordinated groups, must choose their timing carefully when facing a herd with tight formation and very few openings. Water buffalo do not possess the speed of antelope or the sharp teeth of predators, but their muscle strength, endurance, and especially their group-based defensive strategy make them one of the most secure large herbivores along Africa's river systems. Along the Nile, the ecosystem is not shaped only by large species in the water or on the bank. In the air, several bird species maintain a continuous network of interactions between the water surface and the sky. Among them, the darter, the African fish eagle, and the marabou stork represent three distinct layers of activity. In calm stretches with dense reeds, in the air layer, just above the water, the African fish eagle maintains a wide field of view. Its sharp vision allows it to detect fish movement when light reflects off the surface. Its steep dive and the locking motion of its talons are characteristic hunting behaviors. When fish become less abundant, it expands its diet but continues to regulate fish density and prevent oxygen shortages in narrow water bodies. In the mudflats and shallow areas, the marabou stork occupies the final stage of decomposition. Its tall body and bare neck allow it to access carcasses without excessive moisture or contamination. It processes the remains of large animals washed down the river or dead fish from drying pools. By removing organic material quickly, the marabou helps limit bacterial spread during the dry season when natural decomposition slows. These three birds operate in three ecological layers. The darter in deeper water, the fish eagle at the surface and in the air, and the marabou in the decomposition zone. This clear division of function forms a complementary system. Through this network, the Nile's surface remains stable between predators, fish populations, and scavengers throughout the year.